asymptote is at -1 here, then the degree, so earlier this was the non-permissible value, so the denominator. So the degree in the numerator is equal to the degree in the denominator. Okay? So that means there must be an x something. Okay? Now what is that something though? There's a factor there, x something there. Okay? Now what is this something here is based on the x-intercept. Okay? So we have an x-intercept of 1 and 0. So if we have an x-intercept at 1 and 0, that means that we have a factor of x minus 1 at the top, right? Okay? Because in order for the x-intercept to be 1 and 0, then the numerator factor has to be equal to 0 there, so it's x minus 1 there. Okay? Okay, now you notice I left a little bit of space here because I want to consider if there's any stretching involved. Okay? So how do we figure out if there is stretching involved or not? Then we need to use another point. Okay? So you could use either 2 and 1, or you could use 4 and -3, or even 5 and
Does that matter though?
2. So if you use those exact points here, substitute the x and the y here, then you just solve for what a is. Okay? Okay, so I'm going to substitute 2 and 1. So this will be 2 minus 1 all over 2 minus 3. Okay, so this will be 1, and this will be -1. Okay, so then notice how a here is -1. So in fact, we found out that there is a reflection. Okay, okay, so therefore, this equation is going to be negative bracket x minus 1 all over x minus 3, or if you write it a little bit nicer, it will be 1 minus x over x minus 3. So that's just a little bit nicer. Okay. Okay, last one here, it says for B, we have a point of discontinuity at 4 and 1, so this is my pole. Okay, vertical asymptote at -2, so those are my non-permissible value. So the non-permissible value, so that means that we have x equals to 4, x and -2. So my equation will have x minus 4, x plus 2 as my factors at the bottom. Okay, those are my non-permissible values, right? So these are